Before calibration, we should prepare the following things: a set of MFD620C, a straight beam probe, an interconnect cable, a CS15 test block, some coolant. First of all, we need to connect the probe to the MFD620C with the interconnect cable, then start the instrument by pressing the power button, and we get into main program interface. Secondly, press the channel button and choose an empty channel. By rotating the rotary knob, attention please, CH with an asterisk before means the channel has been used and has data stored. CH without any asterisk means empty channel available. For MFD620C, there are 1000 data stored channels in all. After channel selection, press the probe button, and then set up the parameters of probe type, probe frequency, and wafer size. We can do the parameter setting with the rotary knob and direction buttons. Thirdly, press the button F2 and enter the P-delay submenu. By using the straight beam probe to test on steel block, the material sound velocity should be set to 5,920 mm per second, which is the velocity of longitude wave in steel. We need to set the start distance to 225 mm, that is test block thickness, and then set the terminal distance to 450 mm, that is double the test block thickness. After that, press the range button and set the test range to a value which is a little more than double the test block thickness. Here, let's make it 500 mm. This operation is to ensure that we can see both the first echo and the second echo on the screen. After all the parameter settings, put the straight beam probe on CS15 test block and move the probe trying to obtain 2 clear echoes. If you can't get a clear echo, press the gain button to manually by rotating the knob. According to the instruction of the instrument, move the probe so that the gate will cover the highest echo of the 225 reflector, and press F5 to continue. Then move the probe to make the gate cover the highest echo of 450 mm reflector, and press F5 to finish the calibration. For example, as shown in the picture, these 3 lines are AVG curves prepared in advance by a flat bottom hole test block with a diameter of 2 mm. The wave is the workpiece and is in zone 2. The upper line is phi 3 aperture curve, and the middle line is phi 2 aperture curve. Then the size of this defect can be judged between 2 mm and 3 mm. Making method of the AVG curve. Press the AVG button. Then press F2 to enter AVG curve production interface. Select Make AVG, press Confirm to start production. The probe frequency, size, and the material velocity have been adjusted. Now keep the default value and press F5 to continue. Secondly, press F2 and choose the flat bottom hole in the basic item. The maximum depth of the targeted reflection hole is 200 mm. Then set the diameter of the hole to 2 mm. Press F5 to confirm. Moving the probe on the CS15 block, trying to find the highest echo of the hole. The hole in the block, please attention, the hole with a diameter of 2 mm. is at the depth of 200 mm of the block. After finding the highest echo, we should lock it with gate A and then press gain button to make the echo height cover 80% of the screen. F5 to record the measuring point. The instrument can automatically record the location and height of the echo. Meanwhile, generate AVG curve. Press F1 button to finish the measuring record. Set the surface compensation according to actual demand. Confirm by F5. Fifthly, press F3 and choose the whole setting item, and input your required diameters for the upline, midline, and downline. Here, let's make them as 1 mm, 2 mm, and 3 mm. This curve takes a flat bottom hole with a 2 mm diameter and locating at 200 mm, and makes 3 mm, 2 mm, and 1 mm as diameters of the upline, midline, and downline. Then AVG curve is made.